Hello everyone, my name is Bella Guo. I'm a DevOps engineer on the infrastructure engineering team at Wizards of the Coast. If you're not familiar with us, we're a game company, and we make Magic: The Gathering and Dungeons & Dragons. As a DevOps engineer, I typically live with kind of a foot in both worlds. In fact, until recently, I was trading off weeks between DevOps and Dev. I'm here to talk about our game's homegrown Kubernetes build system, or, in other words, did we reinvent the wheel? During this talk, we'll aim to answer these questions. What motivated us? Or why we eschewed existing infrastructure as code and CI/CD tools? How does our build system even work? Was it a good idea for us to write our own build system? What are some alternatives? Or what I wish we had known or considered before we'd gotten started. We started this project over 2 years ago by now, and at the very beginning, we came up with some requirements. First, we required that this build system be easy to pick up for developers who are new to Kubernetes. We wanted something to get us off the ground and running quickly, especially considering that our entire team at that point was fairly new to Kubernetes. We wanted this build system to be fully automated because nobody likes going in and manually spinning up infrastructure. That sounds like a pain. We wanted to have fast development cycles because nobody wants to sit and wait for code to deploy forever. These developers, perhaps somewhat uniquely and certainly very ambitiously, wanted control over their own environments. In other words, they didn't want a black box Kubernetes cluster handed to them by DevOps, and instead wanted to manage their own Kubernetes clusters. We as a team were fairly split between Windows and Linux, and we still are fairly split between Windows and Linux now. So whatever build system that we come up with needs to work in both operating systems. And finally, we required that this build system work for our other clouds. Including other clouds, the community-based tools just didn't support very well at the time. We wanted to avoid vendor lock-in. So now we'll give you a rough overview of what our solution ended up looking like. Because we wanted something to get us going quickly, we ended up deciding on a Python-based wrapper that does some rudimentary variable replacement and calls some CLI tools like kops, kubectl, the AWS CLI, among others. It creates everything you need for a new development environment with a one-line command. We split it up into 3 main sections: code, image, and cluster. First, we check to see if we have a cluster at all. If we do, fantastic, we'll continue. Otherwise, we'll begin spinning up a Kubernetes cluster with kops. Then, we'll compile our code and replace variables in our Docker files. Using our brand new Docker files, we'll build these Docker images, push them up to our ECR repository, or your favorite Docker repository of choice, and replace variables in the Kubernetes manifests now that we have the Docker image tags. And then finally, we'll deploy these Kubernetes manifests. Doing the variable replacement like this allows us to have different flavors of environments. For example, our QA environment can have more memory and more CPU for each Kubernetes deployment than for our personal development clusters. And we can also have a separate soak test cluster that has much more CPU and much more memory than our development clusters. And in separating out the cluster deployment, we can also just pick a different node type so that our nodes themselves are bigger for our soak clusters than for our personal development clusters, for example. Overall, though, this is just a Python wrapper around various CLI commands. Now, if you were listening very carefully, you may have heard me say AWS CLI a few times, and the question might occur to you, why aren't these people using Bodo? And the answer would be, at the time, we were fairly new to Kubernetes, and we wanted command line fallbacks. We wanted to see exactly what command we're running, and we also wanted the ability to just copy and paste that command into terminal and try running the command again ourselves. This would help us debug. So we'll talk about the strengths and weaknesses of our build system. The first weakness is that we make too many assumptions about naming conventions. Because we're using KOps to spin up our clusters, we got used to expected VPC or security group names. In fact, we ran into a bug recently where KOps changed a node naming convention with a version update, and that actually broke our build system. We had to get everybody on to the old version of KOps. The next weakness is that CLI commands may not actually be the way to go after all, especially considering that there are so many differences between Windows and Linux terminals. Windows also has lots of different flavors of terminals, such as PowerShell, Cygwin, Bash, etc. Some of these, we even ran into issues with getting the AWS CLI to work at all with our build system. Perhaps these command line fallbacks were too big of a crutch for us, and we didn't actually need them. Perhaps using Bodo or a similar tool may actually be a better solution. Then the weakness that has become apparent in the past few months is that as our team expanded, ideas have gotten lost. For example, on the previous slide, we talked about separating our build system into 3 separate sections: code, image, and then cluster. However, over time, the waters have gotten muddied and the sections have started bleeding into each other. The initial idea was that we would be able to compile the code without ever knowing anything about the Kubernetes cluster, or we could just do the variable replacement for the Kubernetes manifests and just deploy that without knowing anything about the code and the image. While we can still deploy replace Kubernetes manifests variables, we really rely on having a Kubernetes cluster, since that's our step 0. Make sure we have a Kubernetes cluster up and running. As an example, somebody once removed the initial cluster check, but later it was added back in. We removed it because we wanted to segregate the Kubernetes cluster bits into its own step, but we added it back to speed up cluster creation. Perhaps we could have done a better job communicating that change. So now we'll move on to talking about the strengths of our Kubernetes build system. It's really easy to spin up new environments. This is especially great for client developers who are dabbling in services work. For example, if they have a client change and just need to make a couple services tweaks to make sure that there's to hook up their client calls. It's easy to get going with it, and there are really low startup costs. It hides a lot of the required Kubernetes knowledge and just lets you spin up your cluster and deploy your code without that much of a fuss. It's easy. The next strength is that it's easy to add new functionality. It's easy to explain how our build system works since we wrote it, which means we better understand how it works. And as such, it's easy to add new functionality once you understand it. Because of how rudimentary our build system is, there aren't that many moving pieces, so it's relatively easy to change. Then we come to the core question. Was it even a good idea? And, well, like all good questions, the answer is, it depends. We'll talk about these core trade-offs we made in developing this build system. First, we decided this should be really easy for people who are new to Kubernetes. I think we did a pretty good job minimizing startup costs. However, this meant that we made things harder for people who are experienced with Kubernetes because we built our own system to fit our needs instead of using something established. This means that new hires who are experienced with Kubernetes don't really get to use their existing Helm knowledge, for example, since we're not using Helm right now. So instead, these people who are experienced with Helm instead have to learn our custom system, which is perhaps a little bit more complicated at certain parts than it needs to be. The next major trade-off we made was that our build system was organically grown. It did everything we needed as we needed it. It was really great for getting us off the ground and getting started. However, this also means that we didn't necessarily always plan our build system out far enough in advance. For example, we recently moved from local in-cluster Mongo to hosted cloud-based Mongo. In doing so, we needed to add a bunch of extra networking. And to add this extra networking, we had to add in a bunch of extra AWS CLI calls, which is perhaps complicating it further than it needs to be, especially considering that we're relying on names staying the same to figure out which VPC is our cluster's VPC, so that way we can connect to it with Mongo. The last trade-off was that this build system was really made for developers. It's really easy for development and for developers to use. It offers lots of flexibility. It offers really fast iterations. However, this means that it's rather difficult for release management. If we were to do a deployment now, we'd need to pull the repo and build the code from there. That's an awful way to do a deployment because there's not like a neatly packaged up deployment that we can ship off. Instead, we have to build the code, and if something goes wrong, well, there's little assurance that it's the same thing as what QA tested. So now we'll talk about some alternatives or things that I wish we had considered using. So first is that we perhaps could be using Terraform. Terraform is great for avoiding an over-reliance on naming conventions staying the same. We could also be using Helm to manage our Kubernetes deployments, so that way we are a little bit more friendly to production. Instead of having a Kubernetes deployment be created by running through our build system, we could instead just have a Helm chart to hand off to our release management teams. We also didn't spend that much time thinking about whether we should be using KOps, EKS, or another cluster management tool. We really just used KOps because it was the first tool suggested to us, and we don't really need to do anything special with our control plane. We could just be heading that off to EKS. It gives us a little bit more vendor lock-in, but a Kubernetes cluster is still a Kubernetes cluster. Our game is going to run on any cloud's Kubernetes cluster. And finally, we perhaps could have considered sharing clusters. Perhaps this is a failing on my part, where I could have pushed the developers a little bit harder to share a Kubernetes cluster, where we use kube namespaces for isolation. This would require us to have better routing rules and service versioning to avoid developers trampling each other's network traffic. But at the time, we, as a team, believed in clusters should be cattle, perhaps a little bit too strongly, because at times, we didn't always troubleshoot our clusters when something went wrong. We could just delete it and recreate it because of how easy the build system made it. This meant that we sometimes may be missing out on important care and feeding lessons. And so here are some reflections on how this project has gone so far. If I'd given this talk last year, I probably would have claimed that continuing to use our build system was perfectly fine, and I would have been horribly wrong, because our build system is really designed for developers. It's not really fit for production. When we started our project, we as a team were kind of new to Kubernetes, and we're a little bit scared of existing tools because of the additional complexity they would bring into our system. Additionally, existing tools have dramatically improved since we started. If our current team got sent to 2 years ago and told to start over, we would probably choose to use existing tools from 2 years ago just because we're so much more familiar with Kubernetes as a team now. And as I've said before, at some point we needed to start thinking about how this build system might look like in production. And perhaps we should have started thinking about this sooner, but I'm glad we're thinking about it now. So, in conclusion, yes, we did reinvent the wheel. It's kind of lumpy and disfigured, but it runs pretty well in development. Existing community-based tools, though, have become very slick and elegant wheels since we started. Were we right to do so? To reinvent the wheel? At the time, I think so. It offered us a really fast way to get started working on this project. Were we right to continue to use our homegrown build system? Probably not. We probably should have thought about switching to a dedicated tool someone else wrote at some point, just because it probably is going to be more robust and better planned than our tool. And finally, should you make your own build system? Well, probably not, considering how easy to use existing tools are. And that's it. Thanks for coming to my talk.